Hey there, awesome physics students. Let's do a quick trig review of some of the ideas and principles you need to know from trigonometry and right triangles in order to successfully resolve vectors into their components. So you recall that when we resolved vectors into their components, we always found a right triangle that we could use to find the values of the sides. And the defining characteristic of a right triangle is that it has a right angle that is a 90-degree angle. So here I've drawn a right triangle. The side that's opposite to the right angle, the 90-degree angle, is called the hypotenuse. So I'm just going to label that real quick. And then we need an angle that we're going to use to relate all these sides to each other. So I'm going to call that angle theta. Now this side here on the bottom is right next to this angle theta, or adjacent to it. So I'm going to call that the adjacent side, ADJ. And this side here, this vertical side, is opposite to the angle, so I'm going to call that opposite. Okay. So the relationships between these, the trig functions that you need to know, are the sine function. Of course, the sine is defined as just a ratio of sides. So in physics, we always think about units. This is a ratio of sides, so that's going to be the ratio of the opposite side to the hypotenuse. And because it's a ratio of sides, the units, if these were distances, would cancel out, and the sine will have no units at all. It's just a ratio of sides. The cosine of this is going to be defined as the adjacent side over the hypotenuse. And finally, we can, just for completeness, there's one other function where you could relate the adjacent and the opposite. That's the tangent function. And tangent is opposite over adjacent. Okay. Now, we mostly use the sine and the cosine in our vector resolution here. Okay. One other thing that you're going to need to know is that since it's a right triangle, that you can relate the hypotenuse to the lengths of the adjacent and the opposite sides directly using the Pythagorean theorem. So if I square the hypotenuse, that's equal to the adjacent side squared plus the opposite side squared. Okay, and that's just the Pythagorean theorem. Now, in a practical sense, you can relate these sides to each other using some simple algebra, starting with these key functions here. But usually what I do is I want to solve for the adjacent side. So to do that, I can write out the, I can start with this, cosine function here. That's going to be the adjacent side over the hypotenuse. And that's the cosine of the angle here. And then I just multiply both sides by hypotenuse. And that gives me the adjacent side is going to equal to the hypotenuse times the cosine of the angle theta. And all I did there was I just multiplied both sides by the hypotenuse. Okay, so I multiply by, let me just do that explicitly here. Okay, and so then that cancels it here and leaves us with this expression here. And I can do a similar thing with the sine function here. I can take, start with sine is equal to opposite over hypotenuse. And I just multiply both sides by the hypotenuse. And of course it cancels from the bottom here. That was my intention. And I can solve for the opposite side here. The opposite side is equal to the hypotenuse times the sine of the angle theta. Okay? And that's why whenever I refer to these sides, we're just solving for this vector component here or this vector component here. That would be the vertical part or the horizontal part. And so I just take, I sort of shortcut that by taking the hypotenuse and then multiplying it by either sine or cosine, trying to remember, okay, do I want the opposite side or do I want is this side opposite or is this side adjacent? So if I'm trying to solve for this side, I just use the sine function. And I know that I always have to multiply it by the hypotenuse, okay? All right, hopefully this is helpful for vector resolution, and I'll see you later.